Permutations with restrictions. Example number 1. Let us find the number of permutations of the letters in the word formula if, so first, there is no restrictions. So from here, from the word formula, our n is equal to 7 because we have 7 letters. And since there is no restriction, we can have 77, so that is simply 7 factorial. So we have 7 factorial will be equal to 5,040 ways. Or that means if we have 7 spaces for the word formula, so 1, 2, 3, 4, 5, 6, 7. So in the first place, we can use, there are 7 possible letters to be used. And then for an instance, if we have used one of those letters, we can have here 6 already. And then 5. Then 4, 3, 2, and then 1. Or that is simply 7 factorial. That is 7 times 6 times 5 times 4 times 3 times 2 times 1. Or that is simply equal to 5,040 ways. So if there is no restriction. Next, if the first letter must be L, so again, we have the first letter should be L. And then we still have the other remaining letters. So we still have 6 spaces here. So 1, 2, 3, 4, 5, 6. So for the word formula, we have 7 letters again. So we have one way to have the first letter L here times. So remember, we have other letters left. So we have the F, O, R, M, U, and A. So there are 6 letters for the 6 spaces. So that would be 1 times 6 factorial. Okay, or 1 times 6p6. That would be equal to 6 factorial again. So that is 6 times 5 times 4 times 3 times 2 times 1. So that is simply equal to 720 ways. Next condition, if the vowels must be together. So from the word formula, the vowels are O, U, and A. So we have 3 vowels from the word formula. So if the vowels must be together, so let's say the first 3 positions will be occupied by these 3 vowels. So this one will be considered as 1 already. And then we still have the other letters or the consonants. We still have 4 remaining spaces. So in that case, this one is considered as 1. So 1 times 1, 2, 3, 4, 5. So we have here 5 factorial times. So our vowels O, U, and A can still be arranged. So that would be 3 factorial. Or that would be again 5p5 or times 3p3. So yung 5 factorial will be equal to 5 factorial times 3 factorial will be equal to 720 ways. And then if the vowels must not be together. So the same thing, a while ago we have solved that if we have to use all the letters from the word formula with no restriction, that is 7 factorial, then we'll just have to subtract it from the vowels together. So we can have 77 minus, a while ago we have the 5p5 times 3p3, or the vowels are together. So you will have here 7 factorial minus the quantity of 5 factorial times 3 factorial. Or again, 7 factorial is 5040 minus this 5 factorial times 3 factorial is equal to 720. So we'll have here 5040 minus 720 will be equal to 4,320 ways. And then the next condition, if starts with letter A. So again, we have 7 spaces for the word formula. And then if the first letter should be A, so it's already one way, times there are other 6 letters to be arranged in 6 positions. So that would be 6 factorial or 6p6. So that would be 1 times 6 factorial. So that is still equal to 720 ways. And then if we need to start with letter A and then ends with letter U. So again, we have 1, 2, 3, 4, 5, 6, 7 letters. If the first letter is A and it ends with U, so it's already 1 times. So this one is also 1 way. We still have 1, 2, 3, 4, 5. So 5 spaces for the remaining 5 letters. So that would be 1 times 5 factorial times 1. So again, that would be equal to 5 factorial, or that is equal to 120 ways. If the first and last places are consonants, so when we talk about consonants, so from the word formula, the consonants are F, R, M, and L, because our OUA are vowels. So we have 4 consonants from the word formula. So if the first and last places are consonants, so again we have 1, 2, 3, 4, 5, 6, 7. So let's say for the first position here, it will be occupied by any of these consonants. So we can have 4 possible letters to be used. Then let's say we use F here. For the last place, we still have other 3 left consonants. So we have times 3 here. And then we still have 1, 2, 3, 4, 5. So 5 letters to be used. So that would be 4 times 5 factorial times 3. So again, we have 4 times 5 factorial times 3. That will be equal to 1,440 ways. Okay, next, we have the consonants and vowels occupy alternate position. So again, the vowels are O, U, and A. So we have 3 vowels from the word formula. And then we have the consonants F, R, M, L. So we have 4 consonants. So in this case, since we have to occupy alternate position from the 7 spaces, the word formula, so we can have here our 3 vowels. So that would be 3 factorial times, for our consonants, we have 4 factorial. Or that could be 4 factorial times 3 factorial, or simply 144 ways. And the next, if the last letter must be consonant, so again we have 7 spaces. So if the last letter must be consonant, so again we have here, it could be F, R, M, or L. So we have here 4 possible letters to be used. Then let's say we use F here, so we still have 1, 2, 3, 4, 5, 6 other letters to be arranged. So that would be 6 factorial times 4. Or that is 6p6 times 4. That would be equal to 2,880 ways. Okay, none of them should begin with O. So in this case, again, we have the 7 spaces. So in this case, if we have to take the number of arrangements, if the first letter or it begins with O, so that is simply 1 times 6 factorial, or that is 6 factorial. So since we are looking for the arrangements in which none of them should begin with O, we can have the total arrangements with no restriction, that is 7 factorial minus 6 factorial. That would be the number of arrangements if we started with letter O. So again, that is 7p7 minus 6p6. That would be equal to 4,320 ways. And then if we have vowels that are together and consonants are together. So again, the vowels are O, U, and A. And then the consonants are F, R, M, L. So those are the vowels and the consonants from the word formula. So again, we have 7 spaces. And then, as stated, we have vowels are together and consonants that are together. So first, for our vowels, we have 3 factorial ways. And then for the consonants, we have 4 factorial ways. And remember, since they must be together, so we can have first OUA before the consonants, or vice versa. So that's why we can still arrange it into 2 ways, or 2 factorial. So that could be 4p4 times 3p3 times 2p2, or that is 4 factorial times 3 factorial times 2 factorial. So the order does not matter here. So that would be equal to 288 ways. Example number 2. Let us consider the 5-letter arrangements of the word distance. How many arrangements can be formed if we have conditions? Now, in this example number 2, we have the permutations of n objects taken r at a time. Unlike in the first example, we have to take all at a time. So in this case, we have the values of r is 5 and our n, 1, 2, 3, 4, 5, 6, 7, 8. We have 8 letters as the total letters from the word distance. And then we just have to take 5 letters. So the first condition, it contains only consonants. So again, we have to take 5 letters only. So 1, 2, 3, 4, 5. So the consonants from the word distance are D, S, T, and C. So actually, we have 1, 2, 3, 4, 5. So there are 5 consonants to be placed in 5 positions. So that would be equal to 5 factorial. Or that is 5p5. That is simply equal to 120 arrangements. Next condition starts with D and ends with E. So again, we have 5 spaces. So our condition is it will start with letter D and it will end with letter E. So this is already one way. This is another one way. And take note, we have 3 spaces left. And since we have a total of 8 letters, we only use 2 letters here. We still have 6 letters to be used, to be filled in these 3 spaces. So we can have 1 times 6 P3. So again, times 1. This 6 would be the 6 letters left after we use D and E as the first and the last letter. And then 3 because we only have 3 spaces. So we have 1 times 6P3 times 1. So that is simply 6 objects taken 3 at a time. So we can have here 6 from 6, then we'll take 3. So 6 times 5 times 4. That is simply equal to 120 arrangements. Okay, next. It contains the letter E. So again, we have 5 spaces. So in this case, so let's say we have our E in the first position. So it could be in the first, could be in the second, third, fourth, or fifth. So we have 5 ways to arrange that E. So it could be first, second, third, fourth, or the fifth position. Times, if we have to use E, we still have 7 letters left. And then from that 7 letters, there are only 4 spaces. So times 7, P, 4. So we have 4,200 arrangements. Okay, next. Have the CE together. So we have 5 spaces again. So let's say the first and the second would be our CE. So since they are together, this one will be considered as 1. So we have already 1, 2, 3, 4. So your CE can be placed here 1, could be 2, 3, or 4. So there must be 4 ways. Times, our CE can be arranged into 2 ways. It could be CE or EC. Times, we still have other 6 letters aside from C and E. So there are other 6 letters to be filled in with our 3 spaces. So that would be times 6 P3. So again, we have 4 times 2 times 6 P3, or that would be 4 times 2 times. So again, 6 P3 could be 6 times 5 times 4. And that is simplified as 960 arrangements. Example number 3. How many ways can the letters in the word parallel be arranged if P and E are together? So as you have noticed, we have the word parallel in which we have 2 A's and 3 L's. So in this case, we have distinguishable permutation. And we have our condition to be arranged if P and E must be together. So again, we have from the word parallel, we have 8 letters. We have P, A, R, A, L, L, E, L. So we have N as equal to 8. And then we have 2A. So we have our A is equal to 2, or N sub 1 is equal to 2. And then we have L. We have 3 letter L. And then for our P and R, they are repeated once. So we disregard that. So we only have to take these letters. So since we have P and E that are together, so we have 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 letters from the word parallel. So let's say our P and E will be placed in the first and second position. Since they are together, this will be considered as 1. And then we have 1, 2, 3, 4, 5, 6, 7. So we have 7 factorial times, again, this PE could be arranged as PE or EP. So that would be 2 ways. All over, so since we are dealing with distinguishable permutations, we have to divide this with the repeated letters. So we have A, which is equal to 2 factorial, and our L with 3. So 3 factorial. So again, we have 7 factorial times 2 or 2 factorial over 2 factorial times 3 factorial. So the 2 factorial will be cancelled. We'll have 7 factorial over 3 factorial. That would be equal to 840 ways. Example number 4. In how many ways can 7 people sitting at a round table be arranged? So we are dealing now with circular permutation. So our n is equal to 7, and we have the following conditions. So first, if there is no restriction, so again, we have our n, which is equal to 7. So we simply have 7 minus 1 factorial. That becomes 6 factorial. And that 6 factorial will be equal to 720 ways. And then next, if 2 people must sit next to each other. So let us just imagine if we have an arrangement in a circular manner. So 1, 2, 3, 4, 5, 6, 7. For example, this is a circular table, and the 2 people must sit next to each other. So let's say these 2 positions. This one will be considered as 1. And then we still have 1, 2, 3, 4, 5, 6. So our n now becomes 6. So therefore, we'll have here 6 minus 1 factorial times. So since the 2 people here can be arranged also into 2 ways, so we have times 2 factorial or times 2. That would be equal to 5 factorial times 2 factorial, and that would be equal to 240 ways. And then if 2 people must not sit next to each other, so what are we going to do? As we have solved a while ago, that if there is no restrictions, we can have from 7 people, that is already 7 minus 1 factorial, or simply 6 factorial. And then if 2 people must sit next to each other, we have solved that. We have there 5 factorial times 2 factorial. So we can subtract it. So we have, so again, we have here 6 factorial minus 5 factorial times 2 factorial. So simplifying that, we have 480 ways.